Hi, this is Juan from JuanTutors.com. Welcome to my totally free office hours. Today we're working on the August 2016 New York Geometry Common Core Regents problem number 25. If you want to access these exams anywhere in the world, go to nysedregents.org and click on the appropriate tabs. So here's the problem. Lines AE and BD are tangent to circles O and P at A, E, B, and D, as shown in the diagram below. I'm going to pause the reading for now because when you're reading this is a lot to take in, so you should at least in a cursory way take in the information that they just said. So, and by the way, it is expected that you're going to have to read this more than once. 4 times is the average, so just letting you know. So AE is here, and BD is here. And let's see, it's tangent to circles O and P at A, E, B, and D. So I know what tangent lines are. These are tangent, just skimming the circles, and that's what they're saying. And they intersect at C, it looks like. And if AC to CE is 5:3, the ratio of AC to CE is 5:3, and BD is 56. BD is 56. Determine and state the length of CD. So CD is the line segment we got to calculate the length of. Okay, so definitely pause the video. Try this problem on your own. See if you can get anything with the problem. Remember, this is a part 2 question. So if you do mostly correct work, but you have one error, but you get to a final answer using that one error, you will get a point as long as it's partially correct. That's generally true. So as a general rule of thumb, definitely keep going and always keep going until you get an answer. So definitely pause the video, try the problem on your own, and see if you get the same answer as us. And if you do, definitely hit the like button so you can let us know. So this is what we're going to do. We see that AE and BD are tangent to the circles, okay? And they intersect at C. And we want to know how to get possible lengths, but now we do know that the ratio of AC to CE is 5:3, okay? This is going to be a very useful tool, and BD equals 56, so BD equals 56. That's important, and determine the length of CD. So it's like, what do we do here? Well, there is something that we can do. Here's what the first thing that we should notice, that this object has a line of symmetry. If we go through circle, the center O, through C, through P, that line is a line of symmetry of this diagram. So as a result, AC is congruent to BC, and also CD is congruent to CE. Okay, that's a big hint. So if that's enough for you to get the answer, pause now and try it. But we're going to keep going. We want to get BD. That's our goal eventually. So now, how can we use this ratio AC to CE is 5:3? This is a trick, by the way, that works frequently for a lot of different types of problems. So I want you to remember this. If you happen to know that two quantities are in a ratio with each other, in a known ratio, but you don't need the ratio, you need the actual quantities to work with, so you could do some algebra. There's a quick way to get the ratios, the lengths as actual values. You bring in a variable. So what I'm going to do is I'm going to call AC. Well, AC to CE is 5:3, so I'm going to call AC the length 5x, and now the length of CE is 3x. So it seems like I did nothing much here, but now I could actually do algebra with those numbers. That's the big deal. So now the line that I drew earlier is the line of symmetry of this diagram, which means that the length of BC is also 5x, and the length of CD is also 3x. Okay, so now we actually have lengths that we can do algebra with, and we can write an equation. We know that the length of BD is 56. So BD is 56. So we also know that BD is equal to BC plus CD. So BD is equal to BC plus CD by the segment addition postulate, right? Segment addition postulate. And the benefit of bringing that x in is that now we actually have numbers we can put in here. BD is 56, it's given to us. But BC is now 5x, and CD is now 3x. And now that's an algebraic equation we can solve. So 8x equals 56. Divide by 8. And we get x, let's scroll a little bit, equals 7. Okay? And now we need the length of CD. Let's make sure we determine and state the length of CD. Let's not go and do something silly like solve for the wrong thing, right? We want the length of CD. And then, but we remember CD equals 3x, which is equal to 3 times 7, which is equal to 21. That's it. CD equals 21, and that's 2 points. So the major thing that I wanted you to get out of this solution is this idea that if you know that two quantities are in a certain specific ratio, but you don't need the ratio, you need the actual quantities to do algebra with, you can give them values by just putting an x in there. The ratio is 5 to 3, so let the length of AC be 5x, let the length of CE be 3x, and now you can do all the algebra that you need to do, and that it works every time. So if you just wanted the answer to this question, that's it. You got it. It's 21. But we did create an extra problem for you if you wanted to get additional practice. It looks very similar to the previous problem. Line AE and BD are lines AE and BD are tangents to circle O and P at A, E, B, and D as before, and then radius OA of circle O and radius PE of circle P are drawn, okay, and line OCP is drawn as shown in the diagram below. So if AC to CE is 5 to 3 and OA is 56, okay, then what is the length of PE? So notice that while I was reading, I don't know if you could see my tiny mouse pointer, but I was actually, when I was reading, I was looking at the diagram. It does take, on average, 4 readings of this problem to really get all the information. So don't say, I just read this problem and I don't know how to do it, let me move on to the next one. No, read it 4 times. If you have to, because that really is what's expected. So now pause the video, read it another 3 times if you need to, so you can get some information out of it. Try the problem on your own, see if you can get the answer. And again, if you get it right, hit the like button. And by the way, subscribe, because you know we have a lot of videos in geometry. We have the whole Regents out, we have Regents in algebra, algebra 2, trig, this, geometry, biochem, physics, all of that. So definitely look out for those, and let your friends know that we're here also, because we're here to help. So let's see, what do we do here? We want the length of PE. Okay, we want the length of PE. So eventually we want to get that. So how do we get this? Well, here's this kind of, to me, looks like a similar triangle type situation, because these 2 triangles seem to be, they seem to be similar. So let's see if they are similar. ACE and OCP intersect at C. So as a result, this angle and this angle are vertical angles, and as a result, they're congruent. Angle ACO is congruent to angle let me use the vertices that are corresponding to each other, ECP, because vertical angles are congruent. Okay? Angle OAC is a right angle, and angle PEC is a right angle, because, so angle A and angle, I'm sorry, that's not angle A, because there's three different angles there. So angle CAO and angles, let's see, CEP are right angles. Because tangents Now, in a proof, hold on, I'll say it in a second, because tangents and radii that intersect on the same point are perpendicular. Now, I will say this is not a proof problem, so anyone who, and with a keen eye on proofs would have noticed that what I had said is normally on a statement reason proof, it's actually two, it needs to be separated into two statements, or three even, and you have to say that OA and AC are perpendicular because tangent and the radius that intersect on the same point are perpendicular. Then you need to say that PE and EC are perpendicular because tangents, for the same reason, tangents and radii that intersect on the same point are perpendicular. And then you have to say that angle OAC and angle PEC are right angles, and then the reason for that is that perpendicular lines form right angles. And then you have to say that angle OAC or CAO, angle CAO and angle CEP are congruent because right angles are congruent. That would be if you had a statement reason problem. So that would be like a part 3 or part 4 problem. But we're not on a part 3 or part 4 problem. We're just on a part 2 problem. So that's all. This is all we had to really say. And this in fact is just an explanation for you. So now I've gotten two pairs of angles on each of these two triangles that are congruent. So as a result, the triangles are similar. So the conclusion is that triangle OAC is similar to triangle PEC because, well, the angle is congruent to angle. The angle postulate. So these two triangles are similar, and then as a result, by CPCTC, OA over PE is equal to AC over EC because corresponding parts of similar triangles are proportional. Okay, corresponding parts of similar triangles are proportional. So that's the reason. So and now I can plug in some numbers. Let's see, OA equals 56. Let's see, and this is 5x, and this is 3x, and let's call this R. We need the length of P. Well, we don't have to call it anything. We could call it PE. So OA is 56 over PE is PE, unknown, but it's what we're looking for, so it's okay that it's unknown. And then the ratio AC to EC is 5 to 3, 5 over 3. Or you could do 5x over 3x, but the x's cancel out. I know a lot of the kids love cross multiplying, so I'm gonna do it by cross multiplying, and I get let's see, 56 times 3. 56 times 3 equals 3. I'm sorry, not 3. 5 times PE. I divide by 5. And I get PE is equal to 56 times 3 over 5. That's a decimal, so let's do it. 56 times 3 over 5. 33.6. 33.6. There we go. And that's the length of PE. And of course, I always recommend checking your answer, making sure that on the calculator, 33.6 over 56 is, well, this is the smaller, I'm sorry, let me do it in the other order. The larger one over the bigger one, over the smaller one, because this is the order that they gave it to us in the problem. The ratio should be 5 to 3. 56 divided by 33.6. This should be a ratio of 5 to 3, also known as 1.66, repeating, and that's exactly what it is. So we've checked our answer. This answer is absolutely correct. Hopefully you got the same answer that we did. If you did, I'm very proud of you. And listen, I know you can do it. As I always say, look, all you got to do is keep working at it. Definitely keep watching these videos because I know they're going to help you in the end. Thanks for watching, and stay tuned for the next video starting right now.